Hi everyone, welcome to Easy DIY. My name is Matt, and in today's beginner's lesson, we're going to be talking all things screws and screwdrivers. I'm going to be showing you the most common types of screws, the parts that make up a screw, and most importantly, where and when to use them so that they use most effectively. And we also will have a look at all the drivers that go with them. And stick around for the end when I'll give you my 5 really useful tips for working with screws. First, let's get into the makeup of screws and the terminology used to describe all the parts. Screws are generally made up of 5 different parts: the head, the drive, the shank, the thread, and the tip. The head of a screw comes in many shapes and sizes, but the two most common are countersunk and non-countersunk. Countersunk screws are designed to sit below the surface of the material so that they are out of the way. They can be used to produce a neater, cleaner look in furniture and cabinetry, but because they're physically concealed, they are better for use in situations like decks and hinges, where you can't have the head of the screw protruding. Non-countersunk or dome head screws sit on the surface of the material. You'll often see them holding thin metal components together because the metal isn't thick enough to countersink the hole, and the flat underside of the head provides a good contact and strength to the material. Let's now look at the drive. The drive is the part of the head that the screwdriver goes in. The drive is designed to provide the best connection between the screw and the driver. There are lots of different shaped drives, but here are some of the most popular. The slotted drive was first used in the late 1400s. Now used in woodworking, electrical work, and simple household repairs, this type of screw, although still used today, got superseded by Phillips head screws along with the advent of power drills and drivers. Slotted drive screws don't work well with power drills, as the blade of the driver easily slips off, and due to their design are prone to stripping of the metal, which therefore can render the screw unusable. The Phillips head drive was invented by Henry F. Phillips in the early 1930s for the automotive industry, and today are the most widely used drive in the market. Phillips head screws were invented to resist cam out, which is the technical term for the driver slipping out of the screw and damaging it. It's important to select the right size screwdriver for the screw to prevent cam out. The most common sizes are PH1, PH2 and PH3, and most screwdriver sets come with these as standard. There are many more sizes, even tiny ones for watchmaking and electronics. Since Henry's invention back in the 30s, there have been many different drive designs come onto the market to help reduce cam out. PosiDrive, which is similar to Phillips but with extra notches between the main slots, which gives it a greater surface area contact between the screw and the driver. And they come in sizes PZ0 to PZ5. Hex drive screws are hexagonal in shape and are also called Allen screws. They come in many different sizes and can be used with both drivers and Allen keys. Square drives, or Robinson drives, are often used in decks and woodworking. There are Robertson screwdrivers, but square drive screws are generally designed for battery drills. Torque screws are a 6-point star-shaped screw. They were originally used as a security type design to prevent people from undoing and removing parts out of electronic equipment. They've become more common because they provide good resistance to cam out. The shank is the main body of the screw which connects the head to the tip. Sometimes the top part of the shank will not have any thread, which is sometimes called the shoulder or body. These are normally wood screws that produce a tighter fit. Here I've got a screw with nearly all thread, so it has no shoulder. I'm trying to join these two pieces of wood and also pull them together. When the head hits the wood, it doesn't pull the pieces together because of the thread. Here I have a screw with no thread at the top of the screw. When the head hits the top of the wood, the threaded part of the screw will pull the bottom piece of wood up towards the top piece because the thin, unthreaded shoulder of the screw doesn't grip into the wood. The thread is the part which winds its way around and up the shank. Again, threads come in various sizes for various applications. Timber screws generally have a coarser thread, meaning the thread is a lot wider in relation to the shank. The reason for this is that timber is softer than metal and therefore needs a wider thread to get a good grip in the wood. Metal thread screws are normally finer and closer together, and they're generally used when the material is metal. The tip of the screw is the sharp end of the screw and is designed to break through the material and guide the screw through in a straight line. Most screws are tapered to a sharp point, but self-tapping screws have different tips to allow for removal of material as the screw moves through. Tapping refers to making grooves in the material that the thread sits in. Self-tapping screws can generally be used directly on soft timber, but when used on hardwoods or metal, they might need a pilot hole, depending on the thickness of the material. If drilling a pilot hole in timber, use a drill bit about the same diameter as the shank. In metal, a lot depends on the type and thickness of the metal, but generally it only needs to be slightly thinner than the thread. Self-drilling screws have a tip shaped like the tip of a drill bit and don't need a pilot hole because the tip does all the drilling. So there you have it, the anatomy of a screw. Now let's go through my 5 tips for working with screws. Number 1, choosing the right screw for the job. Many hardware stores will offer help when choosing a screw, but here are some things to think about before buying. If your screw is going to be living outside, it's important to choose one that is resistant to corrosion. Screws are made from many different materials and some have a coating to extend their life. Galvanized coated screws have a high level of corrosion resistance and are quite inexpensive. Stainless steel are the best for corrosion resistance but can be brittle and are also quite expensive. Zinc coated screws are best for indoors as they aren't as weather resistant or as expensive as galvanized and stainless. The other things to think about when choosing a screw are the thread type. Am I screwing into timber or metal? The screw head, countersunk or dome. The drive type. This may be dependent on the type of drivers you have at home and what the hardware store stocks as well. And the tip type. Do I want self-tapping, self-drilling screw or not? You also need to consider the screw length and thickness. The shank is measured in gauges. It's important to get the right gauge for the material. The length is crucial too because when you're screwing 2 pieces together, the screw needs to be long enough to hold securely, but not too long to come out the other side. Tip number 2 is about storage. Screws should be stored in a dry place that's easily accessible. Don't do a me and just keep your screws in their packets in a tub on the shelf. Get yourself some containers that are suitable for storage and organise them into all the different types. Trust me, it'll save you hours searching for the one. Tip number 3, screwdrivers and drivers. Hardware stores have great kits these days that can be inexpensive and good quality. It's a good idea to have the common sizes of flat and Phillips head as well as a small precision kit. Driver kits are also available that have most of the common drive shapes that I've shown in the video. Tip number 4, find your favourite. I have a few types of screws that I always keep a stock of. For me, they're 8 or 10 gauge, around 40mm long, in countersunk and dome head. I also buy these kits, which are super handy as they have a wide range of different size screws and come in a handy case. Tip number 5, keep all the screws you find because you never know when you'll need them. As an example, when putting together flat packs, sometimes you get a few spares left over. I have this container that has a random assortment of odd screws and I'm always using them. So there you have it, a beginner's guide to screws. There's so much more to learn in the world of screws, but I hope this gives you a basic understanding of what's involved. Thanks for watching.